guys. So before I begin, let me introduce myself. My name is Zein Elfikri, but you can call me L. I'm from MB 4810, and my name is 104012430032. On this occasion, I want to talk about metrics. So the metric is from economic mathematics, our lesson. Before we start, I want to tell you about my content in this presentation. So there are metrics, type of metrics number operation, determinant metrics, inverse metrics, adjoint metrics, linear equation, and the last one is Cramer's rule. So we continue to what is the meaning of matrix. So a matrix is a collection of numbers arranged in rows and columns and placed in brackets. So what you can see from this picture below, so matrix in mathematics explain like this: A equal to A11, A12, A13. So the name from this, is row. Okay, like this. So A11, A11, A12, A13, and also A21, A22, A23, like this. We call this row. And also A31, A31, A32, and A33, we call this also a row. Okay. And what is the meaning from the columns here? So the column is the direction to the below, A11, like A21, A31. So this is the column. And also A12, A22, A32 is also, we call this columns. And the last one, A13, A23, A33 is also, we call this column. Okay. So we can conclude that like this: if we have A, then the first number is 1, and also the first number we write here 2. So the first number we talk about from this, the meaning is row. Okay, but if we have 3 after the first number, we call this, what we call this? So yes, it's a row. Okay. Sorry, we call this column. Okay. Next to the next presentation. Continue. Right now we talk about types of metrics. So there are row metrics. The first one, like you can see, we have this. Yeah, row metric. Yeah, based on his name, like row. Yeah, to the side or to the right, like that. And the second one is column metrics, like what you can see from this picture below. Uh, A11, A21, A31, A41 to the down, to the below, like that. And continue to third one is square metrics, like this, because why his name is square? Because the shape from this metric likes the square, like this. Okay, we have 2 and 2 here, 5 and 1 here, and also like this square, 1, 3, 5, 7, 9, 7, like that. 30, 15, 15, and 17 here. The shape like this, square like this. Okay. Next to the last one is diagonal matrix. Why diagonal? Because the shape like diagonal like this: A11, A22, A33, A44, and last one A55. Then 5 times 5 is, we call this diagonal. Okay. Go, we erase this first. So we'll continue to next lesson. So matrix number operation. Here we have if A equal to A11, A2, A12, A13, A21, A22, A23, like this. So we have 2 times 3 of matrix, yeah, row and columns. 3 for row, yeah, and 2 for columns. And we have also B11, B12, B13, etc. We have also 3 for row and 2 for column. Then, if we want to count the A plus B, what should we do? Okay, then we have to plus A11 to B11. Why? Because because it's matrix, we must count this matrix equal with the same places, like this. Okay, A11 plus B11, like that. Like here also, A12 plus B12. Why? Because here to here. Okay, the other one, A13 plus B13, this, like this. Okay, and also for the number below, it's same. The counting is same. Then we continue to this number below. If A 1, 2, 3, 4 mean 3, 7, and B 1, 3, 4, 7, 8, 9 mean 3, then if we plus A and B, yeah, from the past calculation, we can conclude that 1 mean 3. Yeah, the same places like this. 2 plus 4, 2 here, and plus 4 here, and 3 plus 7. Okay. And for the other number, the same calculation. So we have the result is mean to 1, 1 minus 3 is mean 2, and 2 plus 4 is 6, 3 plus 7 is 10, 4 plus 8 is 12, mean 3 plus 9 is 6, 7 minus 3 is 4, like that. So the easy one, yeah. Okay, we next to the next step. So this is the example for minus, yeah. We have also like this. A mean B, for example, 1, 2, 3, 4 mean 7, mean 3, 7, and B mean 3, 4, 7, 8, 9 mean 7. Then A mean B is also the same, but the difference is here is mean, because before is plus, like. Okay, 1 minus 3, yeah, and 2 minus 4, and also 3 minus 7. But why here is 1 plus 3? Because minus meet with minus is plus. Because of that, here the result is plus. Okay? And also the calculation from here and here, and the other one is same. So the result is 4. 1 plus 3 is 4. Here, yeah. 2 minus 4 is mean 2. And 3 minus 7 is mean 4. And also the 4 minus 8 is mean 4. Mean 3 minus 9 is mean 12. 7 plus 3 is 10. Like that. So the result is this. Okay. Continue to the next example. If we want to calculate B mean A, is also the same. Yeah. We just reverse the calculation. Yeah. In the past, we calculate that A mean B. Right now, B mean A. So the calculation is saying uh, mean 3 minus 1 to here, 4 minus 2 to here, 7 minus 3 to here. Yeah. So we have the last result is mean 4. Mean 3 minus 1 is mean 4. 4 minus 2 is 2. 7 minus 3 is 4. 8 minus 4 is 4. 9 plus 3 is 12. Minus 3 minus 7 is 10. Minus 10. Okay? Easy one, yeah? We next to the next lesson. We continue to the next lesson. Yeah. Erase this before. Okay. Okay. We have different methods here. Uh, if A, B, C, D, B, P, Q, R, S, then we have square matrix. Yeah. So here is the calculation for multiple by or times. We can see here, if we want to times or multiple AB, then we times with PR and also AB to TS. Okay, then we have the result here. AB, A, A times P plus B times R, A times K plus B times S, C times P plus D times R, C times K plus D times S. Like this, okay? You can see the picture here. So we're next to the next example. So we have square matrix. The number is 1, 2, 3, 4 times 2, 5, 6, 7, 8. Then we using this method, yeah, using this method. So 1 times 2, 5 first. Then we add plus here. Then 2 times to 7 like this. Okay. Okay, where is this? So we are not confused. Yeah. So, and also 1 6 plus 2 times 8. Where did this come from? Yeah. And also like the beginning first. I like the beginning. 1 times to 6. Yeah. This row to this column like that. Okay. Then 2 times to 8 like this. Okay. And also for 3 times 5 plus 4 times 7, it's come from this to this. And also 3 times 6 plus 4 times 8 is row this 3 4 row 3 4 times to this row, this column, sorry. Okay, then we have the result from this calculation. 1 times 5 plus 2 times 7 is 90. And 1 times 6 plus 2 times 8 is 22. 3 times 5 plus 4 times 7 is 43. And the last one, 3 times 6 plus 4 times 8 is 50. Okay, it's easy. Then we'll continue to the next lesson. So here we have matrix determinant. Yeah. So what is the meaning from matrix determinant? The determinant of a matrix is a scalar value obtained through certain operation on the elements of a square matrix, denoted by a pair of vertical lines or like this. You can see from this picture. So the numerical value of a determinant can be found by multiplying its element diagonally. Determinant of a two-dimensional matrix. So we have example here. Matrix is like this. A equal to A11, A12, A21, A22 like that. Its determinant we add this symbol, yeah, like this. So the meaning is a determinant. A11, A12, A21, A22, like this. Its numerical value is A11, like this, yeah. You can see this result. This comes from A11 multiply to A22. Then we add minus A22 uh, times to A12, like this. Okay. We continue to the next lesson. So, the determinant of a three-dimensional matrix can be solved using the Sarus method. What is the meaning from Sarus method? So, we practice here. So, we have A11, A12, A13, etc. We calculate with determinant, so we add symbol this. Yeah, the meaning is a determinant. So, the numerical value is we need if the direction to calculate to the right, like this, diagonal, the green line, yeah. So uh we put the calculation to plus, like this, plus, okay. But if you calculate to this, like this, from under to up, like this, then we must add minus, like this, okay. So before of that, what we must calculate, like this, A11 times, yeah, times with A22 times with A33, then plus, okay. Then we have this. And also A12 times with A23 times with A31, then we add plus. And also from this, and we calculate, if we want to calculate A31 times with A22 times with A13, then we add minus, okay? Like this, and the last one like this. So we have uh, the calculation like this, okay? Okay, we continue to the example. Where if we have example 1, 2, 3, 4, 5, 6, 7, 8, 9, then we have like this. 1 times with 5 times with 9. Then we add plus here, and 2, 6, 7. Why it is 7? Because like this, we must add two columns before this. So we have 1, 4, 7, 2, 5, oh, 8, 2, 3, 6, 9. Sorry. Oh, we can just add here, yeah. 1, 4, 7, 2, 5, 8, like this. Okay. Then we have 2, 6, 7, and 3, 4, 8. Here and here. Then we calculate 7 times 5 times 3 plus, minus, and 8, 6 times with 1. So this and minus, we add minus. And the last one, 9, 4, 2, and together with multiply times. Then the result is 45 from this, yeah. We erase this before. Okay, so we have the result 1 times 5 times 9 is 45, plus 2 times 7 times 6 times 7 is 84. The plus 2, 3, 4, 8 times to 76, and then we add minus, then the number, etc. 105, 72 minus 48, then the result is 0. Okay? First, Okay, we'll continue to the next lesson, yeah. So we have here matrix determinant minor and cofactor. We have here example A determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the meaning of minor? So the minor of determinant A can be obtained by closing certain rows and columns. MIG can be obtained by closing the ith row and the G column of the determinant A. So we have example here. So M11 5, 6, 8, 9 equal to mean 3. Yeah. So we have here, you must look here. Yeah. M11. So this is row and this is columns. Yeah. We must close this. So we have the number from this. Okay. Then we try to close. Yeah. Okay. M11. Then we close this. Sorry, M1 for row. M11 for column. Then we have this. Yeah. 5, 6, 8, 9. It's equal, right? Okay. We we continue to the next example. We have M12. Then we have one here is row. We must close this and 2 for columns. 2, yeah, columns. 1, 2, like this. So we close this. Then we have a number 4, 6, 7, 9, like this. Okay. And also, the last one, we have M13. We have this 1 for row and 3 for columns. Don't forget to close it. 1, yeah, row, we close this. And column 1, 2, 3, we close this. Then we have 4, 5, 6, 7 is equal, right? Yeah, like that. And we have the result is min 3, min 6, min 3, like that. Okay? Okay, we continue. The solution of the determinant, what you can see like this. And a determinant like this for each row and also for each column. Then we add the numbers to this solution. A11 like that, yeah, like this. Sorry, A11 min 3. So we have this, yeah. Before I wanna tell you A for after the calculation before. So we have one like here, yeah, one, and the capital A is from here like that. Okay, we'll continue to the calculation. We just add the numbers from A small 1 2 and A big 1 2, A plus A13, A big capital 1 3. And then we have the result is 1 times with min 3, then plus 2 times with 6 plus 3 times with min 3. That we continue to the join matrix. So what is meaning from a join? The join of a matrix is a transformation of its cofactor matrix. We have this solution, yeah. A join times with A, then we have this. Okay, we continue. Okay, directly to the example. Suppose A 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we want determinant A 1, 2, 3 is equal, yeah, from before. So the answer, like before, I explained that M11 is we close this and we close this, then we have this. Yeah, like that. And for M12, it's also the same, but we must close this. We open this, yeah. Then we have sorry, we have 4, 7, 6, and 9. Then you can just see the result is like this: min 3, min 6, min 3, min 6, min 12, min 6, min 3, min 6, min 3, like that. We continue the calculation of a joint. We just need to input the numbers up, yeah, the number before, yeah, like this. You can see the result like this, and like this, and like this. Then the adjoint, yeah, we want to calculate the adjoint. We put the numbers here to here, yeah, and here to here also, and also here to here. It's same, yeah, like that, and we'll go down. So this is the adjoint, yeah. It's easy, yeah. So we'll continue to the next lesson. We have inverse matrix. So the inverse matrix can be found using the adjoint and determinant of the corresponding matrix. So we have here A min 1 adjoint with times A to divided by A determinant. A min 1 exists or can be formed if and only A determinant not equal 0. Yeah, that is the disclaimer before. So we continue to the explanation, yeah, the example. Okay, example. Determine the inverse of the matrix. We have A equal to 8, 4, 5, 3. So the answer, the cofactor is like this, yeah. We just directly to the result, 3, min 5, min 4, and 8. So we have this cofactor, yeah. Then the adjoint of A is, we must to include here, yeah, like that. So we have here to here, like this. So what the inverse is? The inverse, we add the result from the up, yeah, from above to this solution. A min 1 adjoint times A divided to A determinant. So we have this, yeah, and this, and A determinant 4, yeah, and the result is this. Okay, continue to next. So we have linear equation matrix. Linear equation consisting of m equation with n variables can be written like this picture you can see. Yeah. If m equal to n and a has an inverse, then we have solution like this. The solution can be obtained by inverting matrix A. So the solution like this. Okay. Uh, we'll continue. So the example. Determine values of x1, x2, and x3. If, like this, we have this. x1 plus x2 min x3 equal to 6. 3x1 min 4x2 plus 2x3 equal to min 2. 2x1 plus 5x2 plus x3 equal to 0. Then the answer is, we have this. Yeah? We need to divide 2. From where can I get this number? So we must to divide this, yeah, to A section, X section, and C. One from this, yeah, X1 here we can see here. One X2 like here we can write here, and min 1 here we can write here. Then we write this X1, X2, X3. Then C is become like from here. Yeah, this is C. Okay, like that. So from that calculation, we have A equal to 1, 1, min 1, 3, min 4, 2, 2, 5, 5, 1, x for x1, x2, x3, C is 6, min 2, and O, and A determinant is 36. Then we add to the solution A min 1, then we have before, yeah, 14 divide to determinant 36. 6 divide to determinant 36, and also min 2 divide to 36 as well as the determinant, like that. Then we continue. Then x equal to a minus 1 c a times with c, like this. Yeah, we must times with c. Then the result is 2, 0, min 4. Then we have so like what I can tell before, like this is x1, this is x2, this is x3. Then we have x1 is 2, x 2 is 0, and x3 is min 4, like this. Simple, yeah. We'll continue. Okay, where is this? Yeah, we'll continue. The last one is the Cramer's rule. So states that the value of variable x1 can be found by substituting the constant value vector C into the A minus column of a matrix A. Then find the determinant and divide it by the original matrix. It's denoted as like this. Yeah, this is the Cramer's rule. Okay, directly to the example. If we must to find x1 and x2 using Cramer's rules, if like this, we have 5x1 plus 0, 4.4 x2 equal to 12. 3x1 plus 3x2 equal to 1. Then the answer we have it here 5 or 0 0.433 x, yeah, x1, x2, yeah, we have x1 and x2 here, and C is from here 12 and 22. Okay, then x1 is, we must add the number here. 12 comes from here, x1, yeah, from here, and 0.4 and 3 is come from here. So we close this and we change with this, like this. Okay, then we have then we add a determinant is 5033, like from here, yeah. Okay, then we have 36 minus 8.4, 15 minus 1 0.2, and the result is 27 minus 27,6, and 13 minus 13,8. Then we divide, the result is 2. Then x2, and also here, yeah. So we have 5, 3 from here. Then we close, because this is 2. We close this and we change with this 12 and 22. And we add, divided, a determinant is 5, like this. Yeah, 5, 0, 4, 3, and 3. Then we have the result 105 minus 3, 6, and 50 minus 1, 2. And we have 69 divided to 13,8, the result is 5. So x1 equal to 2 and x2 equal to x5. Okay? That is the final lesson from me. I hope you enjoy my explanation and uh, my presentation. That's all from me, Metric. Me, I'm Zein Elfikri. Thank you, guys.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I to be presentation about himpunan. Okay, next. Okay, definition of set. A set is a collection of distinct object or element that can be clearly defined. Example, set of vowel A, E, O, U. Set of even number less than 10, 2, 4, 6, 8. Okay, next. Notation and representation. Okay, notation set usually that not by capital letter such A, B, C, and then number two, representation method roster from A 1, 3, 5, 7. The last one, set builder from B X. X is an odd number less than 10. Okay. Hmm. This is type of set. Uh, Empty set. This is symbolic. Uh, and then universal set. This is symbolic. Next, subset. This is symbolic. Next, equal set. This is symbol. Next, complement of a set. A. This is symbol. Union of set. A. Union B. This is symbolic. Intersection of set A. Intersection B. Okay, next. Set operation. Union A, 1, 2, and B, 2, 3, and then A union B, 1, 2, 3. And number two, intersection A, intersection B, so 2. Differency A, differency B, 1. Complement A, element not in A. Okay, next. Venn diagram. This is visually represent relationship between set. Circle represent set, helpful for to understand union and intersection. Next example question: given A 2, 4, 6, and B 4, 5, 6. Fine. Let's go to answer. A union B, so 2, 4, 5, 6 because union. And B, A intersection B 4 and 6 because uh, intersection. The last one, intersection, the last one, A difference B. So answer 2 because difference. Okay, last slide. Conclusion. Set are a fundamental concept in mathematics. They have various types and operation. Venn diagram help in visualizing set relationship. Terima kasih. Thank you.
Hello everyone, my name is Nadhif Dhiyaulhaq Z, and here I will explain the material of linear function. First, we go into the explanation first. So, definition: a linear function is a function that can be written in the form fx equal mx plus b, where fx is the output, also called y. X is the input independent variable, m is the slope of the line, b is the y-intercept, the value of fx when x equals 0. Now we go into key characteristic. The graph of a linear function is always a straight line. The highest power of the variable x is 1. The slope m shows how steep the line is. If m is greater than 0, the line goes up from left to the right. If m is less than 0, the line goes down from left to right. If m is equal to 0, the line is horizontal. The y-intercept b tells where the line crosses the y-axis. Now we go into the example. For the question, is y is equal to x plus 5. So in the question we are told that x is equal to 0. We just put 0 into x. So 2 times 0 plus 5 is equal to 5. So y is equal to 5. For the next question, it is still the same. In this question, it is known that x is equal to 5. So just enter it as before. 2 times 5 plus 5 equal 15. So y is equal to 15. The last question is still the same. In the question, it is known that x is 10. So 2 times x plus 5 is equal 25. Next, we make a linear function graph. From our previous work, we get 0.5, 5.15, and 10.25. The first one is 0.5. We put a dot is here. The second one is 5.15. We put a dot is here. And 10.25, we put a dot is here. After that, we draw a line through the points we have made like this. We go into the exercise slide. Given the linear function y equal to x plus 3, a if x equal 3, b if x equal 7, and c draw a graph of a linear equation. As in the example above, part A is known that x is equal 3. So we just need to enter it. 2 times 3 plus 3 gets 9. So for y it is 9 and x is 3.9. For part B, it is also the same. X is known to be 7, then 2 times 7 plus 3 equals 17. So we get y equals 17 and x equals 7.17. Once we have x and y, we just plug it into the graph. Now, the first one is 3.9. This is 3 for x and this is 9 for y, for the point here. Next, 7.17. This is 7 for x and this is 17 for y, for the point here. The last step is we line following the points like this. Maybe that's just a brief explanation from me about the linear function material. Thank you very much for listening. Goodbye.
Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Davin Ary Sofwany. I'm from MB 4810. Today I will explain about derivative. So, what is exactly is a derivative? In the simple terms, it's about finding the rate of which something changes. You can think about how fast a car is moving or how quickly a population is growing. Derivative help us quantify that change. Okay. First, we have constant rule. This rule states that if you have a number without any variables like x, y, z, or q attributed to it, its derivative is always zero. It doesn't matter if it is a small number or a high number, positive or negative, or even a fraction. If there is no variable and rate of change is zero because it's constant. Okay, for the example, first is derivative of minus 2043. Because it's no variable is zero, and then the second is 154 is zero. Okay, let's move to the power rule. If you have a variable, say x raised to the power, to find its derivative you bring the power down as a multiple in the front of the x, and then you subtract 1 from the power. So there is the formula. Okay, for the example, considering x raised to the power of 20, following the rule, we bring 20 down, then subtract 1 from the exponent. So the derivative is 20x to the power of 19. Sorry, 19. Okay, for the second example is we have 50 roots of x raised to the power of 4 written okay. First, we rewrite this using fraction exponent, which is x raised to the power of 4 over 5. Now, apply the power rule. Bring down the 4 over 5 and subtract 1 from the exponent. This gives us 4 over 5 times x raised to the power of negative 1 over 5. Let's move to number 3. Let's look at 1 over x raised to the power of 7. we can rewrite as this as x raised to the power of negative 7 applied to the power rule. We bring down the negative 7 and subtract 1 from the exponent, giving us negative 7 times x raised to the power of negative 8. Okay, let's talk about the constant multiple rule. If you have a number multiplied by a function of x, like c times function of x, you can simply take the derivative of the function first and then multiply the result by the constant c. In other words, you can pull the constant out of the derivative operation. Okay, we read this as this. Okay, let's move to the example. For the example is the derivative of 7x to the power of 5. According to the rule, we keep the 7 aside and find the derivative of x to the power of 5 first. The derivative of x to the power of 5 is 5x to the power of 4. Then we multiply this by the 7, giving us 7 times 5 x to the power of 4, which is 35x to the power of 4. Okay, moving on to the sum rule. If your derivative involves terms being added or subtract, like function x plus or minus gx, you can find the derivative of each term separately and then add or subtract their results. This makes complex expression much easier to handle. The formula is this. Okay, let's talk about example for the sum rule. For the first example is the derivative of x raised to the power of negative 4 plus 8. We apply the sum rule and take the derivative of each term separately. The derivative of x to the power of 4 is minus 4x to the power of minus 4 subtract 1. For the derivative of 8 is 0. Then the simplify is negative 4x to the power of negative 5. For second example, we have the second derivative of 4 times x raised to the power of 6 minus 3 times x raised to the power of negative 8. We apply the sum rule and constant multiple rule. The derivative of 4x to the power of 6 is 4 times the derivative of x to the power of 6, which is 4 times 6 to the power of 5 is 24x to the power of 5. And then the derivative of minus 3x to the power of negative 8 is negative 3 times the derivative of x to the power of negative 8. And then the result is 24x to the power of negative 9. Okay, let's move to the relative and percentage rates of change. And there is for the formula of relative rates of change. And there is a percentage rate of change formula. Okay, move to the example. The GDP of certain country was NT is T exponent 2 plus 5T plus $106 billion. T is years after 1998. Okay, for the question is, at what rate was the GDP changed with respect to times in 2008? For the second is, at what percentage rate was the GDP changing with respect to times in 2008? Okay, for the solution is, rate of change of the GDP is derivative n accent t is 2t plus 5. The rate of change in 2008 was n accent 10 is 2 times 10 plus 5 is $25 billion per year. Okay, for the second question is the percentage rate of change in the GDP in 2008 was 10 times 25 to 156 is 9.77% per year. Okay, let's move to the product rule. This rule is used when you have two functions multiplied together. If you have a product of two functions, say u, x, and vx, the derivative of their product is the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. We write this as this. Okay, let's differentiate the product. Okay, in this, for example, differentiate the product px is x minus 1, 3 minus 3x minus 2. Okay, for the question is expanding px and using the polynomial rule. For the question B is the product rule. Okay, let's the A question first. And this function can solve with cross multiply. Then there's for the result, and minus 2x minus 3x, this is the result. Okay, so next is find the derivative, and derivative of this function is 6x minus 5. Okay, let's move to B. We identify our two function u and v. Now find their derivative, and derivative of this is 1, and then derivative of this is 3. Okay, now apply the product rule formula. Substitute the value, then simplify the terms, then the combine like terms. Okay, there's the result. Okay, let's move to second derivative, and there is for the formula of derivative. As the name suggests, the second derivative of a function is simply the derivative of its derivative. Is like finding the rate of change of the rate of change. Okay, let's move the derivative example. First, the second derivative of function x is 5x to the power of 4 minus 3x to the power of 2 minus 3x plus 7. Okay, for the solution is we find the first derivative, then the result is this. Okay, let's the question is second derivative, then we must to find the second derivative of this function. Then we got the second derivative is 60x to the power of 2 minus 6. Okay, thank you so much for consider our presentation on derivative. I hope this helped make this concept clearer and easier to understand. Thank you so much for watching. Wassalamualaikum warahmatullahi wabarakatuh.